Hello, my name is Daniel Rutschka. I am responsible for the sales of AI products at IDS. Today, terms or buzzwords such as transfer learning, edge learning, or large vision models don't play a role in the session. Today, it's about what you can do and not what is it called in the end. Talking about the end, after the stream, I will be available for a Q&A session. You can ask questions already during the presentation via the chat function, but I will not be able to answer them right away, so you have to wait till the end. Thank you. For those of you who didn't know so far, OCR means optical character recognition. This involves recognizing and reading out letters, numbers, or characters. These can be printed on paper or applied to a wide variety of surfaces using a direct printing process or marking process. You see an example for printed on the left-hand side and for direct marked on the right-hand side. Here we see some more examples for different kind of marking. Inked on plastic and metal, we see on the left-hand side or on the right top, even casted in the middle on the right-hand side, and scribed on the bottom on the round surface. So, why are we talking about single line? In our case, it is called single line because a word consists of letters, a sentence consists of words, and text blocks consist of a number of lines. We can separate blocks into lines by different characteristics, such as font, size, or color. You see on the left side a text block. You see in the middle a spotting of the single lines within the blocks, and on the right-hand side you see the reading of the single lines. Here are some more examples for direct marking or even casted OCR. I would like to show you more interesting customer applications, but unfortunately, you only rarely get the approval from the customer side. On this side, you see the examples, casted ones, which are hardly to read even by eyes or by human. And you also have examples of casted one that are painted afterwards. And for sure, you also have the scribed ones. You don't only have letters, you also have numbers. Coming back to our initial agenda, I talked about options referring on use cases. The first option is a fixed image acquisition of a known product layout. The position of the text is known and we can work with a fixed region of interest because the text is always at the same spot within our image. No matter what, in any customer case, we would just start with some tests, starting with the standard, or such as say out-of-the-box OCR, working on the cropped image part where the text is located. And as you can see, with a fixed ROE, we just need our standard OCR, read the text, and you will get just a string with the information. If the position of the part is not fixed and the location of the text varies, we can use an object detection to find the item and then use a fixed layout of the item for the region of interest. Or we might use an object detection or instance segmentation to find any kind of text in the first step and then do the reading on the found parts. Something that is described by different kind of buzzwords via marketing at the moment is possible for option 1 and 2. Depending on the quality of the ink or the printing, or maybe some issues with the vision setup, it might be necessary to do an initial training of the OCRNet. In most cases, the out-of-the-box network works so well that an extra round is not necessary at all. But I already had use cases where I had to read many kind of printing, lasering, and even handwriting in a single station, where it only could work out this way. And I must admit, even the handwriting was close to art. I will never forget this kind of circle with a crossbar in it, such as say 9 set the worker. Talking about handwriting, I did a test myself and would like to show you the progress from the initial first view to the inference after the training. So on the left side, you see the same image as on the right-hand side, but you see the progress within the training. So the out-of-the-box net, in this case, I must admit, it's kind of art as well, you can say, this signing. But the results are pretty bad. There's no letter is hidden, I think, and the inference is pretty low. So after a few images and training, the same image was shown, and you can see we are close to 100%. The text is completely right. After having a successful network for OCR, we need to implement it. And therefore, there are different kind of opportunities using the DENK API or even plugins for maybe Halcyon or .NET. In any case, if you need some support or information how you can implement this solution, just contact us and we will help you. So now comes the fun part. We will jump right into the AI Hub and start our first project. Okay, so let's log into the AI Hub. Oh, yeah, let's save it. Now I'm asked if I want to create a new project. So first of all, I would review and just take a look around. So this is the setup. We have an area where we can manage our projects. We see our current networks running. We have a use case wizard if we are not sure what our application is about or which network to use. If we are pretty familiar with the technology, we can switch within the different technologies and just select one by one. So also we have an education center where we can watch videos about how to use different kind of technologies or use or solve certain use cases. But we will go ahead and add a project. We will give it a name, vision channel. Right. I could do a description, but in this case, I think it's obvious it's about OCR. We create a project. I enter. I create a folder. I call it examples. Create the folder. Enter the folder. Upload images or files. Desktop vision channel examples. It's just a random mixture, but I'll take them all. And now we see we are uploading. The first images arrive. So it's done. First of all, I would start with the first image, and just by click onto it, I'm asked if I just want to see the image or if I want to start a project. And yes, we want to start a project. Our headline is today OCR. That's why we don't use the image classification, not the image segmentation, object detection, nor instant segmentation or anomaly detection, and we won't read codes today. So we go ahead with the OCR and give it a name, OCR, because there's only one class. There are not different kind of OCRs in these examples. And we go ahead with this one, this color, save network. So now we see the project is called Vision Channel. The name of the network is OCR. What kind of network is it? It's an OCR network. We have no training set, no validation set, no test set. We have one label, that's called OCR, and no images labeled so far. So we go back to files. And then start with the first image. So this one, I'm a little bit into do it yourself and have to do a lot at home. So we start with the single line OCR prediction. This is equal with our untrained network. So it's the out of the box network, but as I mentioned, it works out pretty well in most cases. And we have different kinds of marking, of labeling. We have the polygon or the bounding box. So we use the bounding box, and I can zoom into the image. So we see a little bit more. We just go ahead by marking this, marking that. This one seems interesting as well. So what we have right now is we see the prediction here and how sure the network is that this is the circumstance or the letters or numbers that are written on it. So in this case, we see everything right. I would do it a little bit more light, and we see it's true. So if we would have this as a project, I would say, yes, that's right, and transfer the prediction into a label, and then just click Save and Next, and it's in the database. But that's not the case, so we are just taking a look around because it's a lot of different kinds. So we just continue. Yes, I don't want to save. So here we have a date, so handwritten date, and I think we will come to this kind of topic later on in the Python integration. We see all numbers, even though they are handwritten, are read exactly, so no false, and it's pretty sure with 92%. One additional information: this is all now done on in a cloud surrounding. So this is just for training or demo use cases. Later on in the implementation at your factory site, it will be downloaded the network, and it depends on the GPU you use, and for sure there are like inference times close to double-digit milliseconds or something. So let's go ahead with the next one. This one. Ooh, here it's a small stamp, but we will see. Let me zoom. SWF, totally fine. So let's go to the next one. Oh, that's a mixture. Let's go ahead with this. Something easy also. Like that. Oh, try something a little bit more difficult. That with this one. And as we can see here also the results written. So if I want to just take a look maybe at the number of this one, so it's 05015766, and as we can see the prediction is 051.766. So if we would be in a labeling process and I would say no, it's wrong, I will click here and get here the suggestion for the label, and I say because it's wrong I need to label it either way, and then I can write just here the right information. Yeah, like Mickey Mouse if I want to. So in this way, no. Okay, but let's scroll out. I think even here we have this one is 0046036, and we have it here 0046036. So even though pretty good so far. So as you can see, why is OCR so popular at the moment? Because it's the easiest way to check it out. You send us some images, or you get an access to the cloud, to the hub, and upload some images, and you see the out of the box function works out so well. In difficult cases, which I mentioned before, when the out of the box solution didn't work out at first place, even though the indication that it will work out or we have a chance was so big, because like there were only like one letter was wrong and it was the regular false, like an A to a 4 or something, which is always kind of a topic. But there are also solutions where we can divide between if we are expecting letters or numbers. Okay, we leave unsaved again. Okay, let's go with the next one. Ooh, this one, it's a cutting disk. Let's start with the diameter, with the size standing there and what it is for. Let's try this one. Here, let me get it. This one is made for Stein, and let's translate it into English. Done by the network, and the type it is. So here's the diameter. We see now exactly the size. It's 125 per 2.5 per 22.23. Let's enable. We see this is correct, but even hard to see. Then Stein, that's what it is for cutting stones. So Stein is the German word for stone. Let's deactivate it so we can see it more properly. So it's the type is C24 RBF. So perfect. So let's try something else on this one. Imagine this is still the out of the box network, and I think if this works, wow. So we have EN12413. That's the norm for cutting disks. Worked out pretty good. So out of the box still. And Germany. So how much more can I say? As a salesman, would be a pleasure to see the face of the customer doing this with an out of the box network. So we enable it, and then the next step, if we have a trained network, we can see here the chart and the evolution of the network, the different iteration, and just push the download button, download network. And then we integrate this one into the DENK API, and how a solution for this one looks into a Python script, I will show you right now. We start with an object detection to find the text, and then we will do an OCR on the detected object. So let's go ahead. So after pushing the download button and having done the integration into the DENKnet API, we will now show an example for the Python code, doing an object detection, finding the text, and afterwards doing an OCR on the text. And therefore we use an example of the best before date on a package of milk, and we start using our peak software to capture the image. And then run our Python script, and we see the results. Here we see the date. I will just highlight it somehow. So it's best before the 19th of June this year, so we still have some time to drink it. But either way, we see the example of the integration into a Python script. This script is available on GitHub. So this is the final point of the session. Now we will continue with the Q&A session. But if you found the topic interesting and you have your own difficult OCR examples, please don't hesitate. Give us a call. It's the easiest way and a quick test to have first results and to evaluate to get further or not. So don't hesitate. Just give me a call. Bye-bye.